Hello everyone, Kaarel here again, continuing our little mini series on PGWatch2, and today we're going to talk about metrics and metric fetching helper functions. So this is the topic list, and let's start with what is a metric in PGWatch2 context. So here there are some details in the slides, but I'm going to jump directly to examples. And so basically, if you look at this deployment diagram here, a metric is something that is stored as a configuration item, and basically it is it can be anything that's a running functioning PostgreSQL query. But yeah, usually those queries then they're not random, let's say, but they look into the internal statistics collector views and give us some information on what is the server doing. And then it's actually executed literally. We're not changing the query. We just, depending on the Postgres version being used for a particular host, we will search for a suitable metric definition if there are many for one metric, and we just execute it as is. And then, of course, store the data in this metric storage database. But in addition, actually, we modify the data a bit. We add some information to make it more usable, more searchable when dashboarding. So in short, metrics, just some bunch of SQL, and meaning it can also be actually from the business domain. So once you set up PGWatch2 for your DevOps needs, you can throw in also some business metrics like sales and whatnot. So why not to show it on some other dashboard? And yeah, so metrics, as I said, they're basically just a bunch of SQL, and luckily you do not need to write you do not need to write your own metric queries. So because we already provide like a bunch of those, like around 40 or 50, I would say, and all important aspects of Postgres are covered. For example, let's look at this DB stats here. That's a really central metric, basically gathering data from this PG stat database system view, giving us a very high level overview of how busy is the database, how many transactions per second are we doing, and how does it look like, which type of operations we're doing there, inserts or rather updates and so forth, and yeah, the shared buffer rates and the number of connected users, all this good stuff. And then why are there so many definitions here? Well, because over time, of course, Postgres has added some new columns to this view, some new bits of information, and we of course want all this good information. So PGWatch2 will automatically select the correct version for your database. And there were also actually two versions here. So we saw that there is a one with _su. So this means like this is a mark, basically like an attribute marker for super users. So PGWatch also knows if your monitoring user is actually a super user. So then we can get usually some more information after the instance. Yeah. Otherwise, the normal definition will be used. So this was the short story about metrics, and this was really simple and plain here, nothing special, but it can actually get a bit more complex. So here we talk about some tag columns, and also of course we need a timestamp. Would be nice to specify it in your query, and the PGWatch delivered metrics or have it as a first column. But the tags, so what are those tags? Here a picture of also like how this metric actually is stored then in the metrics storage database. So we see that, you know, this automatically we get this time column fill and this database name, which is actually not the real database name, but the name we chose for our monitoring entry, and then the data as JSON P. And then the tags system is actually meant to provide fast lookups. So meaning it will be indexed, but obviously we do not want to index everything. So this would, you know, just get maybe slow on the storage, and also so it will use more storage. So you should, you know, really pick and choose what columns are you grouping by, for example, or you need fast searches on. So here an example with tags. And once you define or prefix some column with this tag notation, everything else is taken care of by the framework. So it will just, you know, land into this index column, not in this normal data column. Yeah. Then we also have a concept of custom tags. The custom tags are defined on the database level, so they're not connected strictly with the metric, but basically it can be any data that is useful to you somehow. Okay, so let's take a look at an example. Where do we use this? So we have this sample config entry also defines some custom tags. So basically this can be any string information, and it will be stored for every data row as an extra indexed key value pair. So meaning you should kind of think about it in advance, not to, you know, just store some useless data. And the main idea is might be that you want to, this is for the cases when you want to bring together data from many different systems. So maybe you've got some metrics generated somewhere else, and you want to join the data later in Grafana. So this is one approach. And then there were also some special attributes called the real DB name and sys ID. So they are similar to custom tags, but these data values are activated by a special collector flag. So as already detailed also in the previous episode. And on the storage side, so where do those metrics land in then? So we've got like then 3 schemas when you're using Postgres. I'll be just covering Postgres storage here. InfluxDB doesn't have anything like that. It's just everything automatic, just a bunch of top-level tables. But yeah, here we're basically PGWatch is managing partitions in most cases, or you can also let TimescaleDB do that. And there are some special tables, like listing tables also. And for those cases when you indeed need to add some new metrics, so maybe, you know, a new Postgres version has arrived also, and the project has not yet, you know, coped with that. So it's basically very simple. You know, you just throw your query into in the following like some naming practice, or it's actually like more like a location convention in case of file-based setups. So these are the default metrics you will find from there. For example, when you install PGWatch2, the package, there will be metrics and, for example, wall activity, and then your Postgres version. Meaning, so 9.2 will cover everything up to 9.6. So that's why there is no 9.5 here, maybe in case you're running 9.5. And then there was some kind of change in the information provided from version 10 and upwards. So there are only two definitions. And so this is how like this metric looks like in the end, just a normal query. And yeah, you just pick a name and see what is your minimum supported version, and yeah, just store it. And then the PGWatch collector will pick it up automatically. Actually, the metrics are being cached for 5 minutes, if I remember correctly, and yeah, then they get refreshed automatically, and you can already include them in those preset configs or like a custom config. And here those conventions again about these extra attributes, like do you want this query to be executed in all instance states, or only maybe when it's a primary, in case you're doing some replication tracking. And there's also some support in the GUI for that, adding metrics. So yeah, here you can see the picture. So here, if you go to the metrics page, so yeah, okay, let's just go there maybe then. So webpy, webpy. So let's just go there, and if you go to the metric definitions page, you'll get a listing of all the defined metrics and the versions, and below here you can add your own. Just click new and done. But there are some extra options still. So in case, again, you want to tune the behavior, there are a couple of attributes available for your newly added metric. And of course, there are some attributes defined for the existing metric. So basically so here it's listed, of course, here also, but basically what do those attributes do? Okay, here custom tags again, we covered that. So what can you specify additionally with those things called metric attributes? Well, there was this instance state. Then do you need a super user basically to execute this query? Is it an instance level metric? Meaning, the transaction log location, for example, wall infos, it's basically an instance level information, not database level. Wall is shared over all databases. So you can, if you declare it like that also, you will, improve the performance slightly. So PGWatch2 then will cache this value for 30 seconds by default, I think. You could override it also with some command line parameter or environment variable. And yeah, so if you've got like 10 databases on one instance, definitely you can save some CPU cycles there. And then you can override this statement timeout. You can rename metrics on the storage level. For example, there is only one use case for that currently in the predefined metrics. We have here this metric called start statement, no query text. So this is for the cases where you're not sure about security, and you do not actually want to store the query text also, but only you want to see which query is burning your time by ID, and you know maybe you can later then log in and take a look. How does this query look like? But you, of course, you do not want to have two separate metrics. You want to pretty much see the same dashboards in Grafana. So yeah, so basically they will land in the same page, in the same place. So stat statements and stat statements, no query text. And then you can limit time and day. This is also pretty new. But yeah, basically like a nice thing to have. For example, you've got like some critical business hours, and you do not want to collect any heavy information like bloat levels and such, which could cause a lot of disk activity. And yeah, so this, for example, looks something like that, you know. Or here actually, we specify that we do not want to run this metric during the weekends. You can specify the time also. And then we also had another more obscure attribute called basically it was some extension rename routing or something like that. That we extension version based overrides. Yeah. So when some extensions really change the behavior, and again we look at some extension versions and we actually fetch metrics text like this. We will fetch the metric query from some other differently named metric altogether. So yeah, this is pretty obscure. You won't be needing that. Yeah, so this is how you define those attributes in the web UI, and there are also the explanations. So now another big part of metrics in metrics gathering in pgwatch2 is actually it has to do with the fact that mostly we also want to look at some operating system metrics. And the problem is that Postgres does not really know anything about operating system pretty much. That's why actually it's a good thing also, because it can run on all kinds of weird platforms. But yeah, so how do we get those operating system informations? Well, we need or we can rather, yeah, we can install some helper functions on the databases that we monitor. And those helper functions then can be, for example, some PL Python functions, basically meaning we can use in the unsafe version, we can use the full power of Python, and we can extract arbitrary metrics and then just give them back over this Postgres port basically. And this is what we do out of the box basically, or we assume that you would want some of those helpers. So especially when you're using an unprivileged monitoring user, even without the PG monitor grant that is actually recommended from versions 10 and upwards. This then in that case, if you install those helpers, you will get much more metrics and a better overview. So yeah, there are a lot of wrapper functions already existing, and yeah, so how do they look like? In the metrics listing here, they're just as is there, there is a flag here, so some helper is helper, yeah. And on file-based setups, we are storing them here, and they all start with get something. So yeah, would be nice if you want to add your own, would be nice to probably to adhere to this naming convention. So, and how do they look like? Or maybe this one is maybe not so trivial, but let's take a look at the memory one. Yeah, so very simple actually. Huh? The signature is in plain SQL basically, and then we use the power of Python language in here. And here we also assume that the psutil library is installed. And actually, most operating system helpers rely on psutil. Yeah. And of course, you also need the PL Python Postgres package installed via your package manager. And yeah, so there are the common things, and there are also some more unusual things. Maybe monitoring your backup systems via PGWatch, and even looking at some hard drive health data. So, and how do you roll out those helpers? Well, a couple of options. Manually in a targeted way when you just need one basically maybe. Here we're rolling out this get stat activity, meaning our monitoring user is a pure unprivileged user in a pre-version 10 environment, and he cannot look at the activities of other people. But yeah, after that, so this helper will be security definer wrapper, and it will empower our unprivileged user in a safe way. So basically just selecting out of this activity data as super user. So this is how it works mostly, and the PL Python use case. But you do not have to actually do it manually. So there is like a semi-manual way, or like an en masse way. So we provide like a small Python script that actually can connect to some single databases or instances, or to your configuration repository, be it file-based configuration or in a Postgres config DB, and actually it can roll out all the helpers automatically, or just a list of metrics that you or helpers that you're interested in. So just look at the help and specify the so metrics. So we have here helpers. So we have the rollout helper. Quite some options here also. And there's some built-in rollout capabilities also actually. But this requires super users, so I would not mostly recommend using it. Only when you're maybe doing like a push-based setup, meaning you're on the machine. You're running a PGWatch on the machine that you want to monitor, and then you will store the metrics into some remote database. So then it's kind of safe to use. Yeah. And this was this then this flag where's my command line? So actually let's open a new one. So this was this flag here, basically auto-create helpers, but you need to be super user for it to function. Then it's all automatic. You just need to make sure that PL Python installed and psutil is installed. Good. PG start statements always also recommended, of course. So, And adding helpers, exactly the same process basically as adding normal metrics. So just you need to place it in a different location, or just check this checkbox on the web GUI. So this was here. So is helper. And for those rare cases where actually this our PGWatch default system is not flexible enough, you want let's say to gather some weird information, you cannot do it over the normal Postgres connections. So then actually basically the Postgres metrics in the end are stored in a plain database. So you can feed this database in any way you see fit, basically. And there are some samples also on GitHub where we do it. Like we also do some disk monitoring, but we need to be root here, and we don't want to run Postgres as root and whatnot. So we just gather the data and then insert it into the database ourselves with an insert. But here you really need to know some details. So which metric storage schema are you using? We have some options there. Metric time was the default kind of, or then timescale DB if you're monitoring hundreds of databases. So we're nearing the end. Special metrics. There were most of the metrics seen here are totally normal, queries selecting from PG stat something. But we also have some placeholder metrics or special metrics defined. So they actually do not contain any definitions themselves. They just rely on maybe some other definition files background, like internal definitions, or they just trigger some hard-coded built-in functionality that's existing in the collector. So yeah, change tracking, giving some recommendations on the health of your setup, basically. Server log parsing. So this needs access, of course, to the server log, and we only parse the counts, the error or the fatal or the warning counts. So no error messages. So in that sense, it's safe and doesn't take a lot of space also on the storage side. And then there's a relatively new special metric called instance up, meaning well, with the normal metrics, when the database is down, you do not get anything in the metrics database. You will just get some errors in the server log. But if there is no data, it could from when looking at it, there can be many reasons why there is no data. Is the Postgres down? It was pgwatch2 down? You don't know. So for that reason, there is a special metric instance up that actually, even when the database is not accessible, it will just record the 0 in the is-up column. And this can be used for SLA calculations or for some other reasons also. Yeah, that was it. So hope you learned something, and if you again stumble onto something or get some good ideas, let us know. Have a nice day. Bye bye.